Yes, and on my side, I was working on ideas for cheap improvements of this robot, and also I made function to fix stats and make some refactoring. And like as for improvement, because it's quite interesting, so Victor suggested to remove engines from teleoperation arm and like to move it more freely. And when you do this, you can make improvements on top of this. For example, you can use different velocity on your teleoperation and on your follower arms. For example, like you can see this made on a laptop touchpad. So if I move my mouse quickly, so mouse goes through all the screen, and I move my finger only like couple centimeters, 1 inch. But if I move this 1 inch slowly, cursor moves only a little part of the screen. So in this way you can have much more precise movement of the cursor, and it helps you to make this precise movement. So we can use something similar with robotic arms. And it's interesting that it feels very natural to the human when you use touchpad. You can even not notice this. So if we use this algorithm for arms, then teleoperated arms will be disconnected from follower arms. It will be not mirrored. So it can cause some problems, and model can have some challenges with learning, but this can be interesting way for improvements. And like if we manage to do this, we can make some precise operations like inserting USB cable. We can just move slowly and it will be much more precise. So quite interesting insight.
Okay, I was working with Dynamixel SDK today and did some teleoperation with 2 models, and we can check how it works and play a little bit with speed regulation and see how it works and what we can improve here. And also I investigated the cheap way how to do teleoperation are much cheaper and much faster. It's because when you move teleoperation motor on your side, you should turn this knob with all motor gear, and it have some resistance, and it's need to accelerate a little bit, and it do your movement not so smooth, and usually a motor can reach more speed that you can turn in the teleoperation side. So we can change this motor for only sensor, magnetic sensor, and use it with some sleeving mechanics that can simulate a little bit resistance, but you can do it as small as possible if you need it. And I choose components to use it because you need to connect a lot of magnetic sensors to computer, and they use I2C connection, and it's a little bit problem, but we can use multiplexer and one of type USB programmers that you can buy for Amazon, for example, and order all these parts to get it when it will be needed, when I complete all this design.
Today my task is to add our real robotic arm into the simulation pipeline To do that, I need to learn a little bit about Mujoco robot description file. It's in XML file format, and you see on Mujoco the documentation. There's a page to describe this format. It's a long file. I think I cannot get everything in one day, but it's a good documentation with a lot of references. And the file is already made here. It's an existing file, and I made some change to add some term for in order for this integration. And let's have a try. Run the simulation, teleoperation, and the next step is to connect with Mujoco AR. Yeah, it works. You can see with my cell phone movement, the robotic arm is also moving. And my next step is to add the gripper action, close and open.
Today we have really exciting progress. We start to train something. So to get there, several things happened. I first read the LeRobot or LeRobot, I don't know how to pronounce it. Let's say LeRobot. LeRobot repo, the GitHub repo, and like understood like the basic stuff, how to run certain command, how the data is flowing, and then how to call the training, etc. And after that, I looked into XML files in the Mujoco. So I went through some tutorials and then understand how to make basic modification of XML files. This XML file is describing the world of the Mujoco simulation. So it has things like where's the object, where's the camera, where's the light, what's the material, how's the physics is there, things like that. So given that, I made this green box in front of this robot here. The robot is a LeRobot model that Aurelian made. And I used the phone simulator that we made yesterday and do a very simple motion, like just go up and down, just above this green box. So I recorded 2 episodes. This is the first one, and this is second one. So they look very similar, very simple, and these 2 episodes are going to be our toy training data. And then I wanted to use this toy training data to train something on our training script to make sure that the whole process is running without error. And Igor prepared the training script on the laptop. I bring that to our GPU server, then make sure everything is working there. And this is what we see now. A number of steps, epochs, those values, just normal, usual stuff. You see a number of steps is 38K now. We set 80K as the number of steps. I think it takes about a couple of hours to finish this training for this the small 2-episode toy training data. So yeah, so this is really exciting. Now what we have is we have a way to collect the data. We have a way to set up the robot in the simulator. We can set up the environment in the simulator. And then once we collect this data, and now we can run some training. So what's left is we need to have some evaluation script tomorrow. And then, of course, we want to see how this training going, and then load the checkpoint, and then see what it can do, right? Tomorrow is going to be another exciting day.